Hello everyone, welcome to the next session on ANSYS Workbench tutorials. In this session, we will analyze a CFST column which is of rectangular type for its compressive test. We will start by double-clicking on static structural module. We will first go to engineering data and double-click. The first material that we will create is concrete M30. Density is one of its property, 2300 kg per meter cube. Next, we will give the property of isotropic elasticity. Young's modulus in megapascal is 25 and Poisson's ratio is 0.18. Also, we will give the value of compressive yield strength in megapascal, which is 30. The next material which I will create is steel. Property of density is 7850 kg per meter cube. Then I will give the value of isotropic elasticity. Young's modulus is 200 gigapascals, 200 E9. Poisson's ratio is 0.3. Also, we can give the value of tensile yield strength in megapascal, which is 250. Then I'll go to project and update project. Next, I'll go to geometry and right click. New design modular geometry. We'll first go to units and choose millimeter. XY plane look at. Then I'll go to sketching and choose rectangle as the option. I'll first draw the inner rectangle for the concrete. So I'll give it dimensions. H1 is 80. B2 is 40. This is 20 and L3 will be 40. Then I'll go to modeling and I'll choose extrude option. I'll select the sketch 1, apply. The depth is 3000 mm, which is 3 meter, and generate. So you can see here this is the column. Next I'll go to XY plane again and I want to create another sketch. So I'll select new sketch. I'll go to sketch 2, XY plane. I'll choose rectangle. First I'll draw this rectangle itself which is created, and then I'll draw one more on the outer side. I'll give the dimension to this one. H5 is 100. L7 is 50. L8 is 25 and V6 is 50. So once this is created, we'll go to modeling. We'll click on extrude. We'll select the sketch 2, apply. The depth is 3000 mm. Operation is add frozen, not add material, and generate. So now you can see here this is the outer portion which has been created. So now we'll close the geometry. We'll go to model and double click. We'll first go to geometry and select solid. This is the inner one. So I'll give the material as concrete M30. And for the outer one, I'll give the material as steel. Then I'll go to mesh and generate it. I'm generating a coarse mesh. If you want, you can generate a finer one. Then I'll go to static structural and right click. Insert fixed support. I'll select the face option and then select these two and fix it. Then I'll select the top end and insert a load, that is force. I'll change vector to component. Along the z-axis, I'll give the value as 8000 Newton. Now you can see it is going upward because this is tensile. So I'll just change it to minus 8000 such that it is of compressive type. So once this is done, we can now go to solution option. Right click, insert deformation total. I also want to see the deformation directional along the z-axis. I'll right click and insert strain equivalent. Also I'll insert stress equivalent. I'll go to solution and solve. We'll go to the first deformation. Here you can see the maximum deformation is 0.44763. So we will just click on animation. So you can see this is the pattern of its animation. If you want, you can remove the mesh by clicking no wireframe. Contours, select smooth contour. Now if you animate, you can see this is the pattern of its deformation. Then we will go to directional deformation. This is 0.159 at this top end where we have applied the compressive load. So again you can animate and check the result. Then we'll go to equivalent elastic strain. It is 0.044577. Maximum value. Minimum is 1.264. You can click on max, min and see where it is maximum and where it is minimum. Then we'll go for stress. Again you can see maximum is here, minimum is at this end. You can animate and check, it will give you the same sort of animation. So this gives you the result for this long column which is subjected to a load of 8 kN compressive load. What happens in CST column is the load is shared by the steel column and the concrete both, because of which the column is going to be much more stable and steady as compared to a only concrete column. So with this, I end the session. I hope you understood the analysis. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.